Types of data. In biology, we learn to classify or group animals by kingdom, phylum, class, order, families, genera, and species. Similarly, in botany, plants are classified by their characteristics. In statistics, we can classify our data by its characteristics as well. And knowing the type of data you have in a statistical research study is important, since it allows you to determine what statistical analyses can and cannot be used for that particular study. There are two methods that we use for classifying data. One is simply type classification, and the other is level of measurement classification. Recall from lesson 1 that data is the actual responses or values you get when you're asking about a particular variable. Let's talk about how to classify data by type first. There are two broad categories that data can fall into. You can have qualitative data or you can have quantitative data. Qualitative data involves labels or descriptions of traits that typically involves words or phrases. It could be numbers, however, usually it would be numbers that we don't typically calculate with. It's sometimes also called categorical data because it involves categories. With qualitative data, you want to think about it being a quality, again, or a characteristic of the particular variable. Some examples might be eye color, an ID number, like your GHC ID number, your Social Security's number, your license plate number, gender, ethnicity, political affiliation, your hometown, yes, no, agree, disagree, true, false. Anything that involves words or phrases is typically going to be considered qualitative data. Quantitative data is counts or measurements, which definitely involves numbers, and those numbers we do perform calculations with. It usually involves some kind of quantity or amount. Some examples might be things like height, weight, age, pulse rate, amount of rain, exam scores, and temperature. Quantitative data, if you have numbers, it can be broken down into two additional groups. Quantitative data can be either discrete or continuous. Discrete data is the result of counting 0, 1, 2, 3. It involves whole units, no fractions or decimals, again, because we're counting. Typically, the description will involve the phrase number of, the number of children, the number of books on a shelf, the number of credit cards, the number of eggs a hen lays, the number of calls received in a day. Things where you're counting, you have whole units. Quantitative data can also be continuous. Continuous is the result of measuring. It could involve fractions and or decimals. The data can assume any value, an infinite number of values between two specific numbers. Again, think about using a ruler and how you can have half units or quarter units or eighths or sixteenths. Again, it can be any value in between. Examples, things like height, weight, temperature, distance traveled. This flowchart shows you how the data is classified by type. Your initial decision is whether the data is qualitative or quantitative. If it is quantitative, you have to then determine, is it discrete or continuous? Now let's look at how to classify data by level of measurement. There are 4 levels of measurement: nominal, ordinal, interval, and ratio. The higher the level of measurement, the more mathematical calculations that you can do and the more statistical analyses options that are available to you. So we love to have data at the highest level, which is ratio. That's not always possible, but the higher the level of measurement, the more you can do with the data. So let's consider the 4 levels. Nominal data involves only qualitative data. Remember, qualitative data is words or phrases. It classifies data into mutually exclusive, non-overlapping, exhaustive groups, meaning you have a group for everybody and a person cannot be in more than one group at a time. It has no sense of order or ranking. You cannot do any mathematical calculations. Obviously, it's words. So things like true, false, yes, no, agree, disagree, political affiliation, zip codes, those are considered nominal data or data at the nominal level. Ordinal data also involves just qualitative data, so words and phrases. It still classifies the data into those mutually exclusive, exhaustive groups. But now with ordinal data, you have a sense of order or a sense of ranking. But the differences between those rankings are subjective and open to interpretation by the researcher. Again, we can't really do any mathematical calculations here. Even though we have ranks, you cannot do any addition or subtraction. So things like letter grades, A, B, C, D, F. We know A is better than B, but B is better than C. But really, what's the difference? Survey responses: above average, average, below average, poor. I might think that a particular movie is above average, while you may think it's below average. Again, that's my personal opinion, your personal opinion, so it's very subjective and open to interpretation of the researcher. Again, any kind of judging contest, first, second, third, again, it's based on the opinion of the judges. Third is interval data. Interval data is quantitative data, numbers. We still have that sense of ranking and the sense of order, but now the differences between those rankings can be calculated, be determined. They're very objective and they have meaning. We can add and subtract with interval data. The one characteristic of interval data is that it does not have a true zero, meaning that 0 is simply a placeholder. It does not necessarily mean the absence of something. Temperature is interval data. We know that 32 degrees is colder than 70 degrees, but 0 degrees does not mean there's no heat or no temperature. It simply means it's really, really cold. Calendar dates, IQ scores. Again, 0 does not mean you have no intelligence or no brain. It just means you didn't score very well. Finally, the 4th level is ratio data. Ratio involves quantitative data as well. It has that sense of ranking and sense of order. We can make sense of the differences between the ranks. With ratio data, we can perform the 4 basic operations: add, subtract, multiply, and divide. And ratio data does have a true 0, meaning 0 implies the absence of something or nothing. For example, height. If I say something has a height of 0 inches, I don't have anything. If I say I got 0 phone calls today, I got no phone calls. Nothing. Salary. Exam score. Notice the visual aid. Think about the levels of measurement as a staircase. Nominal is the lowest step. Ratio is the highest. And when you move from ordinal to interval, you move from qualitative to quantitative.